Alright, so in the video yesterday, I showed how to make this global rain effect. And I had a comment asking what to do if we want the objects to move, because as of right now, if you move an object that has the rain effect, the rain just pans with the movement because we are using absolute world position. So today I'm just going to do a quick video and show how to make it so that if you would like the rain to stay local to the object's position and rotation, we can keep the rain local. So right now, yeah, you can see if we move the object, the rain stays in the same spot. It doesn't look horrible, but the problems start happening once we rotate the object, because the rain will keep going in the direction that it was originally rotated in. And so we want to be able to have the rain go down in the exact same direction no matter how it's rotated, and have the rain stick with it. So right now, this is set to a global, and you can see over here, I have a static switch now in the material, so we click local. And now when we move it around, the rain will stay exactly with the object, and however you rotate it, the rain will still end up going straight down. And it's pretty cool because on the sides, like you can see, it's kind of going down this one because it's kind of slanted, and then this one has the rain going down even more. But no matter what, no matter how you rotate it, the rain will keep going in the same direction, and it will stick attached to this object that you have. So how do we do that? It's pretty simple. Before, we were just using absolute world position right here for everything, and we'd plug it in here for this noise, for that noise. So I went around to all the absolute world position nodes, and we are replacing it with a named reroute. So this named reroute comes out of a switch parameter, and that we're calling local. We'll have it set to true by default, and then we output this position named reroute. Then everywhere you had absolute world position, just replace it with this new position node, because it can be either local or global. Here are the locations right there, right there, right there. I think there's 1, 2, 3, 4 of them. And then once you have that set up, we can fill in what this position should be. So first off, for false, if it's not local, we can just keep using absolute world position like we did before. But if they have local turned on true, so you want the effect to stay relative to the thing, we have to make a gravity aligned or local position. Because otherwise, if you rotate it, it's going to, like if you rotate it 180 degrees, the rain will go up instead of down. So we're just making sure that the rain is going down at all times, no matter what is rotated. So first thing we have to get is the rain Z. So we do this by, our down vector, 0, 0, 1, and that's in world space. So now we have to transfer it to local space. So just a quick transform vector. So now we take that down vector in world space, and we are making sure that no matter what the local rotation is, we still have this down vector. That's what the transform does. Then we normalize it, and now we have our local down vector. We dot product that with the local position, and then we have the rain Z. Then we take our local down that we just have, we cross product that with the forward vector, I believe this is, yeah. And then cross, and then we get local right. Then we take local right with our local down, cross product those, now we have local forward. And the reason why we have to do all these separate is because we're only going down on the Z axis. Again, because the noise is stretched out, the Z is different from the other one. So we'd have to do everything separate. We make our local down, local right, local forward, and then we're using these, dot product these together, dot product the local position, local forward together, and now you have rain X, rain Y, and we made rain Z up here. Then you can append them all back together, and now we have our gravity aligned position. So usually if you don't want it to have the rotation, it's a lot easier. You can just replace absolute world position with local position, and the effect will follow around. But all this math basically is to make sure that no matter how the object is rotated, we keep gravity going down at the same global vector. So that's it. It ends up with a pretty cool effect where you can now rotate these and move them, and it will work totally fine. And now you just have a choice between local and global, which you always want to have some static switches in your material functions so you can easily turn them on and off, because each material, you know, is going to have a different use case and different needs that you're going to want to be able to customize. Another note is that sometimes when you add a static switch parameter to your material and then you click apply sometimes it will not update all your materials. This is just a bug in UE5. So make sure, if it seems like your parameters aren't updating, just make sure you save and apply all your materials, all your base materials, as well as the material function, and then it should work. All right, thank you for watching, and have a good rest of your day.